But if you got number 5 wrong, then honestly, write everything that we're writing, including like a sentence to kind of summarize how we solved it. So we have Nigel's class placed 10 empty rain gauges on the playground Monday morning. The line plot below shows the number of inches of rainwater in each gauge after it rained Monday afternoon. And it says, what is the mean amount of rainwater per rain gauge in inches in the 10 rain gauges? So what does it mean when it asks you about the mean? It's asking you to find the average. So you guys remember how to find average? What? Add them all and then divide them by however many you added. And if you notice, these are fractions, right? So I have, and each x is like how many of those occur. So I have to do 3/8 plus 1/2 plus 1/2. So there's 2 1/2, right? Oh, how about I make this a little bit easier? At least for me. So there's 1 3/8, there's 2 1/2, so I'm gonna multiply that by 2. There's 3 5/8. I'm gonna multiply the 5/8 by 3. There's 3 3/4 and 1 7/8, which I'll just pop over there. So multiplying comes first. Again, like this is, you do get a calculator, but it's not Desmos. That'll simplify fractions for you. You don't get to do that. So what you could do is see if it gives you a nice whole number, or if not, you might just have to do the old-fashioned way. But 2 times 1/2, so 2 parentheses, 1 division by 2, close parentheses, now hit equal, and it tells me that it is. That's not correct. See, this is why I hate this calculator. See if I can do it one more time. It's short. So 2 times, in parentheses, 1 is 2, close parentheses, now it equals. Now it gives me the right. You can see why I don't like this calculator and why I want to find it. Because that should be 1 right here. I'll bring down the other stuff. 7/8 plus 3/8 plus 1. Plus, now let's see what this gives us. I already know, because I already know how to do this, that it will not be a nice even number. So you'll just have to follow your normal rules. When you have fractions that you're multiplying, like this is a whole number, for example, you multiply straight across, and then any simplifying you can do at the end. So what's 3 times 5? Good. What's 1 times 8? Okay, good. Now do this one. What's 3 times 3? And it's over 1. So 1 times 4 is. Okay, good. So questions on that first part. All right, so then we are now gonna add up the fractions, but I mean, I guess there's a few ways you could do this. What's the rule for adding fractions? Or subtracting fractions? So what I said was, the rule for adding and subtracting fractions, and Ryan said it, is that they have to have the same denominator. So the first to do for the majority have a denominator of 8. How can I make the 1 have a denominator of 8? What can I do? Or what could I make it? Not 1/8. 8/8 is equivalent to the 1. Right, because 1 is a whole. 1 as a fraction is this. If I want my denominator to be 8, I'll times it by 8. And whatever you do to the bottom, you have to do to the top. So that's how I get 8/8. This one already has a denominator of 8. And then over here, how can I make this one have a denominator of 8? What can I do to that fraction? What can I do to the denominator? If it's a 4. Multiply it by 2. And then whatever you do to the bottom, do to the top. What's 2 times 9? What's 2 times 4? All right, so then I can replace now this fraction with 18/8. Questions on that process? All right, now that they all have the same denominator, I can add them straight across, because the denominator is still gonna be 8. At least for now. So then I have. And always clear your calculator before you start to it. 7 plus 3 plus 8 plus 15 plus 18 is 51. So I have 51/8. Now, don't forget, because all we did so far is add them. What do we have to do to find the average? Divide by however many numbers you added. So remember, the average or the mean, in other words, is the sum of your numbers divided by your number of numbers. Okay, so how many data points did we have? We had 10. So I'm going to take that fraction, 51/8, divided by 10, which, do you guys remember the rule for dividing fractions at all? Keep, change, flip, good. So you keep the first fraction the same. Change the division to multiplication, and this, which if it was written as a fraction, would be 10/1. Now we're gonna flip it. It's gonna be 1/10. And then we just multiply straight across. Any simplifying we can do at the end. What's 51 times 1? And 8 times 10. And does that match one of my answers? Great. And it was the answer supposed to be C? Anyone have it written down? I can pull it up on the key. Let's see. Number 5. Yes, it's supposed to be C. So there you go. Questions on that one? You really should check to see if this should be simplified, but it doesn't. 51 is a prime number, so nothing else goes into it other than 1 in itself. Yes. Yes. Any others that we should review? Brianna? Okay, number 1. So number 1, Juliana divided the part of a number line from 0 to 1 into sections of equal length. She plotted point M on the number line as shown below. And we need to pick of the following circles which one is shaded to represent a fraction that's equivalent to the number represented by point M. So first we need to figure out what fraction would represent this. So how many equal sections do I have? Well, let's see. 1, 2, 3, 4. So you don't count 0 as 1, all right, because that's not a section yet. 1, 2, 3, 4 equal sections total. What part is M on? Like what section? So that means that the fraction that represents the number line is 3/4, and we need to see of our options which one has that same fraction. So remember those test strategies we talked about. First of all, if you have no clue how to do this one, just save it for the end. But first eliminate any obviously wrong answer. So which one could definitely not be 3/4? Definitely not B, because 3/4 is like 75% of the way, so that's too little. C looks weird, honestly. If this was shaded, like not randomly, and it was 3/4, it might look something like this. Does that wedge look like that wedge? So no. All right, the other ones are pretty all similar to each other, huh? So we're gonna actually probably have to do the math, but look, now we're at just 3 options, which is better odds than. So I'll go from bottom to top. How many sections are there in E? 5, 6, I disagree. 12, how many of them are shaded? 1. And when you simplify that, or if you just want to put it in your calculator, 9 divided by 12, does it give you the same decimal as if you did 3 divided by 4? So that, I already know the answer. That has the same decimal, same fraction. If you simplify it, because 3 goes into both, you do get 3. All right, but these other ones real quick have 10 sections. This one has 6 shaded, so that would be 60%, not 75%. And the other one, A, has 10 sections and 8 of them are shaded, so that's 80%, not 75%. Okay, questions on one? Questions on others?
And I did say it at the beginning of the class, but I'll say it again. I did want you to do your corrections in a different color, so I could like give you points for what you were doing today. If you were assessing it.
If you haven't been doing that, start doing it now. You shouldn't be erasing for each one. If you need more room, you need another paper, I'll give you a paper. Questions, Brianna? Number 10. Number 10. Did you need something again? Probably I'll have you start from tomorrow. Are you already going to test? Then yeah, you can start with stuff like that. But table 8 and 9, make sure you don't leave with your packet, because I need a preview point. All right, so number 10 you said, right? Okay, yeah, it was kind of weird, but it tells you a pattern exists among the unit digits of the powers of 7. And what it means by unit digits or units digit is it seems like it's the last number. Okay, so like it says the units digit of 2401 is 1. So when I do these numbers, or at least let me remind myself, it says that there's a pattern. So it's saying what is the units digit of 750? Can we see what the pattern is, anyone, by chance? What's the pattern from the world? Right, so everyone, if you didn't hear that, I'll repeat it. The last digit of each number for the powers of 7 go 1793, 1793, and they just keep going. And they want you to go all the way up to 7 to the power of 50 and see like what one that would be. So really your options for your answers are 1, 7, 9, or 3. So which one should we eliminate right away? Good, so we can eliminate C, score can't even be an option. So you have a few choices. You could make a list of 7 to the power of 9. You don't really even need to know what the power is. I don't think the calculator will tell you because it's too big of a number. But you can make a list all the way up to that and see like what number happens to land on it. Since for 7 to the power of 8, that unit digit was 1. I'm gonna do 50 minus 8. What's 50 minus 8? So I need to see like in 42 spaces, like what number that would be. So there's 4 different options, right? So now I'm gonna do 42 divided by 4. Don't know if that's an even number or not, probably not. Okay, we get 10.5. So that means after the 8, we go through like 10 full rotations of those numbers. And then half a rotation. So then, if we ended on 1. The next one after that would be 7, 9. I think the answer is 9, is it not? Answer E for that one? Yeah. Okay. So did you guys follow my logic there? It's basically like finding the pattern. So look at the keys that they give you. They're telling you that what they mean by unit digit is the last number and either continue the pattern all the way up to 50. Or like I just figured out, there's 4 rotations of numbers. How many rotations did they go through? The last one is 8. And it would end up being 7. Okay, can I trust you not to lose your packets? Or do you need to turn them into so that you don't lose them?